formula, so kind of talk side by side, like what we need from each one. So I did the arithmetic in the first column, the geometric in the second column. The arithmetic sequence one, so the a sub n is used to find the fifth term only, versus s sub n, which is the arithmetic series. If you do s sub 5, that would be the sum of the first 5 terms. Okay, so knowing the difference between a sequence and a series, and then the arithmetic version versus the geometric version. Geometric sequence, if you want the fifth term only, you use a sub 5. If you want the sum of the first 5 terms, you use the series formula. And then this one is your infinite geometric series, which only works when what? Say it again. Absolute value of r is less than 1, which means r needs to be between -1 and 1. So it needs to be sort of a decay sort of thing as opposed to a growth. Because when it is decay, eventually you'll just keep adding on 0, 0, 0, and it doesn't change anything. Okay, so some just general review from the chapter. Your factorial stuff, which 40 factorial, 40 times 39 times 38 and beyond. And then in the denominator you have 4 times 3 times 2 times 1 times 38 and down. So everything 38 thereafter cancels. 40 divided by 4 is 10 over 1. And I can reduce the 10 and the 2 with 5 and 1. I can reduce the 39 and the 3 with 13 and 1. Is that right? 13 and 1. This is just how I'm going to crunch this without a calculator. So 5 times 13 is 65 over 1. So that ends up being just 65. So just understanding what a factorial does and then how to make calculations that seem like they'd be humongous, but they actually chop down kind of nicely. Knowing how to do basic summation notation. So I have 3 summation notations, sigma notation, whatever you want to call it. This one wants me to plug in 1 through 5. That's bearable. This one wants me to plug in 1 through 16. Not so bearable. This one wants me to plug in 1 through 5. Bearable. But the main point of putting these 3 side by side is to know that one of these is arithmetic, one of these is geometric, and one of them is neither. If it is arithmetic or geometric, we can use the series formula for that specific one. If it's neither, we have to do it by hand. Okay? So, who can tell me how I'm going to decide what type that is? Arithmetic, geometric, or neither? Abby. How do you know? You don't know how, you just know.
Different from the other one.
Okay, so what is this one then? How do you know? How do you... Well, we need to work on that. We need to be able to explain things. Oh, how about this one? What's this one? How do you know? Okay, because the I minus 1's in the top is better. Because this I is in the exponent, this has exponential format, so it is geometric. So we got that. I want a better explanation as to why this is arithmetic. You're right, but who can supplement her? Yeah. Well, this. Okay. Better. Anything else that's really going to just give it to me concisely? Succinctly? Is that the right word? I don't know. My vocabulary is terrible. Yeah. Okay, yeah, you're probably getting too specific. I'm just looking for the fact that this is mx plus b. This is a linear format. right? And if it's linear, then it's arithmetic. If it's exponential, then it's geometric. And so these two we can use our series formula for. This one is neither of those. So this one you have no choice but to do by hand. Okay? So your series formula on the arithmetic one would be the number of terms divided by 2. How many terms are there? 16. So we have 16 terms divided by 2. And the first term, you plug in a 1, you get 3 plus 2 is 5. Plus a sub n, the last term, I'm just stealing the formula from the top here. The last term is going to be, once I plug in a 16, 3 times 16 is 48. 48 plus 2 is 50. So we have 8 times 55, which is 440. 8 times 50 is 400. 8 times 5 is 40 more. On the geometric one, when you plug in to your formula, it's S sub 5, because we're plugging in 1 through 5. Your first term, when you plug in a 1, is going to make 1 minus 1, 0. Anything to the 0 power is 1. 2 times 1 is 2. So your first term is 2. 1 minus your r. What's your r here? 1/4. Again, I'm stealing this right from here. To the n power, which is the 5th. All over, I'm doing this one. All over 1 minus r, 1 minus a 4th. So a 4th to the 5th power. We're going to try to do this in our heads, but it might not go well. 4 to the 5th power. 4 times 4 is 16. Times 4 is 32. 64. 128. Did I do that right? Or am I... Oh, wait. 4 times 4 is 16. Times... Oh, yeah, you're right. Times 4 is 64. 64 times 4 is 256. 256 times 4 is 1,016. 1,024. Okay. Yeah, we've maxed out our mental math with that one. So it would be 1 over 1,024. So 1,024 over 1,024 minus 1 over 1,024 would be 1,023 over 1,024. We're not going to go there. So you may expect to see this on a non-calculator section simplified to like being over 3/4, which you then may see a keep, change, flip sort of thing. So if I keep the 2 and change 3/4 to 4/3, that's going to make it 8/3, 1 minus 1/4 to the 5th power. Or it's on a calculator part and you just type it in. That would be great. This one you just manually have no choice but to do it by hand. So when you plug in a 1, you get -1. You plug in a 2, 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5. You plug in a 3, you get 9 times 2 is 18, 18 minus 3 is 15. You plug in a 4, 16 times 2 is 32, 32 minus 3 is 29. And 5 squared is 25 times 2 is 50 minus 3 is 47. And then just add all of those up for your answer. 47, 57, 67, 77, 76, 86, 91, 96, 95. I don't know if you did it the same way, but it should be 95. Being able to take sequences and write them in your own summation notation. So again, my advice was what stays the same, the 3rd power. What's changing, the base. So that's your base. I use K, you can use J, you can use I. And we're starting with a K of 4 and ending with a 13. That one's a fairly simple one. The 4 at the denominator are writing the first 3 terms of any of these sequences with these stipulations, but we're mixing and matching the types here. So the first one is a recursive. So your first term is 9. Your second term is going to be 2 divided by 3 times the previous term, which is 3 times the previous term of 9, which was 2 over 27. to get your third term. You do 2 over 3 times the previous term, and the previous term, gets a little ugly here, was 2/27. What's that? Wait, what? I'm not multiplying the 27 by 3. It's technically 3 over 1. I can reduce the 3 and the 27 to 1 and 9. So it's 2 divided by 2/9, which is 2 times 9/2, which ends up being 9. Oh, that makes it nicer. And so on and so forth. Oh, wait, we're done. It said only 3. The next one gives us the first term and tells us that there's a common difference. So that's pretty straightforward. 3/2. You subtract a half, you're going to be down to 2/2, which is 1. You subtract a half, you're going to be down to 1/2. C is another recursive. Now, why did I put that one on there? I don't know. That one's easy compared to the recursive that we did up here. We're just doubling the previous term and adding 3. So take 4, double it, and add 3. 11. Take that term 11, double it, and add 3. 22 plus 3 is 25. And then the last one just gives us the first term and the common ratio. So we're just multiplying by -1/2. So -8. Then it'll bounce back to a positive 4, and so on. Good? All right. Writing your own formulas. So coming up, taking a sequence, writing your own formula. And you have to know, obviously, your sequence formulas in order to do this. And you also need to be able to identify, hopefully this is the easiest part, whether it's arithmetic or geometric. So this is adding 4. Does it continue to add 4? Yes. So the general formula would be a sub n equals your first term of -7 plus you're adding n minus 1 times the common difference. If you want to put your 4 out in front, you can. You may distribute that 4, and you get 4n minus 11 if you turn it into linear. Again, the next two are more series. As soon as you see the word sum, series. Again, easiest part should be identifying which type, and then that's just going to drive which formula you use. So if it's arithmetic changes, use this one. Geometric changes, use that one. Okay? This is sort of the oddball that's got its own specific use. So this one, adding 3, adding 3, adding 3. We would do s sub 15 equals 15 over 2. First term is -6. Now this one's a little bit tricky because we have to come up with our own last term, right? I think it's easiest to jump back to the sequence formula to find your last term. But some of you, your mind does it differently, and your brain kind of problem solves differently, and you can get it however you want to. But I'm going to do it this way. To find the 15th term, I'm going to take the first term, and I'm going to add the common difference, n minus 1 times. So that's 14 times 3, which is 42. -6 plus 42 is 36. And then crunch numbers that way. (15/2) times 30. The 30 and the 2 is going to reduce to 15 and 1. 15 times 15, 225. And then the next one times ratio of -3, it looks like. So s sub 15 here. This one's probably going to be way too large to do in your head. First term, 1 minus your r to the 15th power over 1 minus your r. And that would definitely be a calculator. Make sure the double negative up top is not a plus, but this one is. And we've talked about that. And then finding the sum of the infinite series, that's that special equation. So your R value has to be between -1 and 1, and what is it here? 1/3, good. So your sum of your infinite series, I don't know if that's proper notation, but I'm going to do it so we know sum of infinite number of terms. If it's not the proper symbol, it should be, because it makes sense, right? Whatever I say, right, Nevada? Whatever I say. Your first term is 9 divided by 1 minus your R. 9 divided by 2/3, keep, change, flip, 27 over 2. And then on any given word problem, I'm thinking of the nursing home one that we did the other day. You have to be able to read into those, and I always coach, like, the first question you need to make sure you're clear on is this a sequence or a series? Are they asking me for the 5th term, or are they asking me indirectly? Because in a word problem, they're going to use the English language, right? They're not going to use math terms. So you've got to read into the word problem and decide, are they technically asking me to add these all up, or are they asking me just for what's happening in the 5th year? That's going to be your determination between a sequence or a series. And then from there, you've got to decide if it's arithmetic or geometric, depending on the pattern that's happening. Identifying your own common difference if it's arithmetic, or identifying your own common ratio if it's geometric. Good? And then you have the option of a word problem that sort of gives you a formula, like this one just gives us the annuity formula. And you do not need to know the annuity formula. That will definitely be given to you if it's on there. So you're depositing 200. That goes in for what letter? P. At the end of each month. So that's how you know it's an annuity, because it's a regular occurrence, kind of scheduled in equal increments. Into an account paying 10% compounded monthly. How much will you save over 18 years? I might have selfishly written this for myself to figure out what my plan is here. Okay? So 200. N is 12 to the 12 times 18 minus 1 are divided into n parts. And then make sure you know how to properly type that in on your calculator. Always, also, not that it's going to be a saving grace all the time, but look at your answer and see if it makes sense, right? Just roughly speaking, if I do $200 times 12 months a year times 18 years, I alone would have put $43,000 into that account. All things considered with interest, knowing that this is banking on 10%, I should get a number that's bigger than that at least, right? And if you know anything about, obviously, how interest compounds over 18 years, it should be quite a bit bigger than that, I would hope. 10%, I mean, you haven't done a ton of these, but you start to get a feel for what percentages really are a large portion, and 10% would be pretty great. So if you get an answer when you type this in that's like 3,000, please recognize that something's wrong and try again. Okay? So what do you get? Anybody? Okay. Well, I don't think I'm going to be getting 10%. But so that's all I got to do is $200 a month for 18 years. Can you leave off the negative part, Grace? All right. So now there's extra problems in the book. Obviously, that's just probably the review at the end of the chapter. If you're looking for more word problems or something in specific that you want more practice with, answers are in the back, so you can always check those. But I also have, did anyone print out the review sheet? You did. So we'll go over any questions on that first, if anybody has questions. If not, we can just tackle random problems. Who's got questions on the review sheet? Grace? Can I have it? Yes. You know, I can't make this up, but my schedules year to year are pretty similar because, you know, the first 2 or 3 years I was ironing things out, but then they kind of settle in and I know what needs 2 days, what needs 1 day, so we always end up at the same spot. I always give a test a day after the Super Bowl. It's not on purpose, it just falls that way. No.
Yeah, I noticed that in the beginning.
Good. It's great. Because I think I might miss the beginning of 9th period, so I'm going to have them start with the video and just.
Jocelyn.
I think I'll be back by 20 minutes into it, so they may never get here. But
Evan's in that class.
Isn't Gianna?
Stuff I've been
okay, 12 and 13, and I'm doing this like this so that if I do run over 20, they still have something to learn from. So 12. What is the first term of the geometric sequence when t sub 8 is 4374 and t sub 3 is 18? So my geometric sequence formula is, I'm going to go with t sub n because that's what they have. It's t sub 1 times the common ratio, n minus 1 times, right? The issue is we are missing, like you have the 8th term, so you could plug in 4374 with an 8, but we're missing the first term and the common ratio. You could plug in 18 with the 3rd term, but again, you're missing 2 things. So does that, the way I just described that, shed light onto a certain way that we should do this? Starts with an S. New. I haven't heard it yet, so hold on. So I'm going to do it. I'm going to do what I just said. The 8 minus 1 would be 7. That's when I plug in that. I'm going to plug in this, the 3rd term. System was what I was going for. But no. And I think the familiarity of what I'm about to do here would depend on how you wrote equations of your own exponential equations last year in Algebra 2. But when I have 2 plugins for something that's exponential, we're used to, when you have things lined up in a system, we're used to doing like elimination, right? Where you add them together or subtract. But because these are not separated by an addition or subtraction sign individually, adding these equations together and subtracting them is not going to work. But if you divide them, 4374 over 18, Lord knows what that is. We're just going to leave it. T sub 1 divided by T sub 1, here's your elimination. It cancels, right? Then your exponent rules, r to the 7th divided by r to the 2nd is r to the 5th. And then you solve for r. So how do we get rid of the 5? 5th root, or I tend to raise to the reciprocal 1/5 power, same thing. So 4374 divided by 18 raised to the 1/5 power is 3. So once you know what the common ratio is, you can go back up. I'll go to the easier one. 18 equals t sub 1 times 3 squared, divide both sides by the 9. The first term is 2. Well, I'm going to tell you that even though this is the formula that the Regents sheet gives kids, that's not the formula I leave my Algebra 2 kids with. I've written my own because I don't like this formula. This formula banks on the fact that you know the first term. So it's very limited in the sense that if you don't know the first term, and instead we have a situation like this where you know some term other than the first term, like the 3rd term and the 8th term, it doesn't allow for that. And it leaves you in this sort of pickle, which isn't terrible to wrap your head around. So the way I do it is I say, well, you don't have to have the first term and the nth term. You could have any two terms. So I switch this like into a K. So where there's a 1, I change it to a K. So I can use K as my third term and N as my 8th term. Do you follow? So what happens, because the logic is the same. If your third term, you know, is 18, your 4th, 5th, 6th, 7th, 8th means you're multiplying by a common ratio how many times? Starting with this number, 18, you're multiplying by R once, twice, 3 times, 4 times, once, twice, 3 times, 4 times, 5 times to get to the 8th term. Hence, N minus K, the 8th term minus the 3rd term. That leaves you multiplying by the common ratio 5 times. But you're not starting with the first term. In the entire sequence, you're starting with whatever starting number they gave you. Because the textbook questions just don't have that, but it's the same stuff. I mean, it's definitely a more challenging question, but that's the review sheet and the source for all these pre-AP questions is not one for one from the textbook. They're 2 totally different sources, so they don't ever line up perfectly. 18 here, and that is your K term, which is the 3rd, so K is 3. N is your 8th term, and that is 4374, and then you just solve for R right from the start. And then once you know R, you can go back and find T sub 1. Worst case scenario, worst case scenario, you'd have to like kind of guess and check. Like 18 times what? 5 times. You'd have to kind of think it through. And that would be sort of a trial and error thing. But we've talked about this concept, right? So even if you don't use these formulas, if you talk about the concept, you're starting with 18 and you're multiplying by the common ratio 5 times, and that's supposed to get you to 4,374. The building of the concept, which we've done, you could use for sure, and maybe that's even easier for all of you. I don't know. It probably is because it makes more sense that we're starting here and multiplying by R 5 times to get to that number. It does make the most conceptual sense versus just trying to force things into a formula that you're not sure about. And 12 would be 13. No. Did you say 12 and 13? Okay. You receive an email asking you to forward it to 4 other people to ensure prosperity. Assuming that no one person breaks the chain and there are no duplications among the recipients, how many emails would have been received and sent after 8 email generations, including yours? Wow, this sounds like my art of problem solving class. I want it to be. Okay. So if person 1 receives an email and they're sending it to 4 other people, there's 4 people that it's been sent to. Those 4 people are then going to send it to 4 more each. So how many total will get sent it on the second layer? 16. This is after 8 days. And then how many people, these 16 all have to send it to 4 people, so that'll be 64, right? So this is, to be careful with how this is worded, how many emails would have been received and sent? And I'm just doing this sending right now. Or, they're probably not doubling it. I have a question for you. And this is probably why I put this on the review sheet and not on the test. Because in doing this problem, I'm wondering, the first person received an email, right? And then he sent it to 4 people. So he sent it to these 4 people. Those are the same 4 people that just now are going to receive it, right? Do you think we're double counting those or no? Yeah, I think that wording is a little bit tricky. I don't think they want us to double it. Like, I don't think they want us to count those 4 sent as also 4 additional received. They probably should have said how many messages were transmitted. That would have covered it without being confusing. Do you follow me? Okay. It's going to do it. You just did S sub 8, and you did a first term of 4. You did a 1, I was going to say, because I think that first person did receive it on day 1. So 1 plus 4 plus 16, you did a series formula with an R of 4, right? That's tricky. That's why that's on the review sheet, not on the test, because I didn't want that to be. I mean, the concept is, but hopefully in a word problem that's not as confusing. Like, because of the nature of, are you going to double count the sent and receive on day 1? Are you sending? But, we're assuming that first person receiving it is being counted as day 1, then day 2, then day 3, then day 4, and so on. Good? Up to 8 days. Anybody else? 7. I know you have more, Grace, but I'm just... What is T sub 31? Okay, perfect case. We're given the 5th term and the 9th term. So conceptually, if I want to ditch that formula that I just gave you with the N and the K, the 6th term, 7th term, 8th term, and 9th term is 22.4. You really have to figure out what your common difference is. So you're starting with 12.4, and you're adding some common difference that we have yet to figure out. Once, twice, 3 times, 4 times, you're adding that common difference before you get 22.4. Yes? So then you solve that, subtract your 12.4. 10? D is 2.5. So now if they want the 31st term, I mean, you can do it a couple ways. You can start with the 9th term. How many times are you going to have to add the common difference to get from the 9th term to the 31st? What's that? Use what just happened here as like a little microcosm. To get from the 5th to the 9th, you had to do it 4 times. That's the difference between the two, right? So to get from 9 to 31, it's going to happen 22 times, because that's the difference. So if I start at 22.4 and I add that common difference 22 times, that's going to land me at the 31st term. Okay? If you didn't want to do that, you could go back to your regular formula and say, okay, if the 5th term is 12.4, and my first term I have to find, but I do know that the common difference is 2.5, and n minus 1, since 12.4 is the 5th term, that's 5 minus 1. You can find your first term, and then once you find your first term and you have your common difference, but then you're sort of going to be doing the formula like 3 times, which is fine. Just slowly but surely find out some piece of information with each step. If you can think your way through it without having to grind through the formula 3 times, I would encourage that. How do you feel about that, Abby? Okay. Other questions? Hold on. Let me think. How many terms are there in a geometric series if the first term is 4? The common ratio is 3 and the sum, yeah, it's like you just kind of plug in what you know. Yep. So they're giving you the grand total. I'm going to show this to everybody because, again, this is a different vantage point. Same formula. It's just I don't know that you've ever been asked to do it in just exactly this way. But you should be able to think through this. They're giving you the series total. So your first term is 4. 1 minus the common ratio to the nth power is what we're searching for. All over 1 minus 3. So, yes, multiply over your -2, divide the 4 away, subtract the 1 away, divide the negative sign away, and then log both sides. Does it work out nicely? Doesn't, so that would be a calculator one. Well, yeah, you can kind of tell by the multiple choices what would be a calculator question. Like whole number ones probably can be done without a calculator. It does. I'm going to keep going with it then. So if I divide by 4, that's negative 80. I don't need those parentheses anymore. Subtract 1, negative 81. Divide by negative 1, you get 81 equals 3 to the n. That's 4. Your number of terms could never be 4.1. Oh. Is it asking for the number of terms? Yeah, if it's asking for the number of terms, how many terms, it has to be a whole number. You can't have like 2.5 terms. So I'd have to look at your work for that. I don't think we have time right now to do it start to finish, but or do we? What do we have, a minute? Oh God, I can do it. I'm up for the challenge. What number am I doing? 15. Sum is 93. First term is 3. 1 minus 2 to the nth power over 1 minus 2. So that's a negative 1. Multiply that over. It's going to be negative 93. Divide by 3 on both sides. Negative 93 divided by 3 is negative 31. Subtract 1 over. That's negative 32. Divide the negative...